Section 1.3, Variables and Sets. This is where things can get a little confusing and abstract, so focus because this is where I started getting lost in the class. So first, some general definitions. A set is a collection of objects, and an element is an object in a set. I could have a set of numbers, a set of people or cities, anything really. For example, we have this set A that has 3 elements, 5, 12, and 72. Since 5 is in this set, we can write 5 is an element of A, and 1 is not an element of A. That's what these E-looking symbols mean. And the basic question when you're defining a set is this element in the set or not? So this set B is wrong because we have 7 listed twice, and you only need to list it once. And this set C is a list of natural numbers greater than 0, so 1, 2, 3, 4, etc. And it goes on infinitely. So rather than listing every single element of this really big set, we can define a set by rule called an elementhood or membership test. So this set C, 1, 2, 3, 4, etc., can be written in a better way below. We can make a set using x's from the set of natural numbers, but we only want the ones that are greater than 0. When you're trying to figure out if an element is in a set or not, you use the elementhood test. So for example, first of all, is that x from the natural numbers? Second of all, is that x greater than 0? If yes to both questions, then that x is an element of this set C. So in general, what you have on the left side of the bar is the sort of numbers or things that you have in consideration. And then on the right side of the bar, you're going to have the rule that defines which ones from that group are you going to pick out to be in this set. And when we have sets that are written in this elementhood test form, we need to keep track of what the variables mean. So our variables can either be bound/dummy variables, or they can be free variables. The name of a bound variable can be changed without affecting the truth value of the statement. It just represents something and acts as a placeholder, really. And when you plug in different values as a free variable, though, the truth value of the statement does change. So for example, to demonstrate bound/dummy variables, we're going to look at these statements here. So y is an element of x, element of the natural numbers, such that x is greater than 0. If we just change the name of the x to say z, for example, on the right side, it doesn't change the meaning of our statement because z was a bound variable. Now, in the examples of free variables, when you plug in different things, that is going to affect the truth value of the statement. So for example, if we have -3 element of the set of x element of the natural numbers such that x is greater than 0, well, this statement is actually false because -3 is actually not an element of this set. It's not a natural number because it doesn't start from 0, 1, 2, 3, 4, etc. And it's not greater than 0. Whereas if we change what we plugged in to 3, then this statement does become true. Like 3 is an element of this set here because it comes from the set of natural numbers and it is also greater than 0. To reinforce our identification of bound and free variables, we're going to look at this example here. To simplify the following statements and identify the bound and the free variables. So when you are looking at this statement, the first thing that's kind of easy to identify is the bound variable. So usually it's going to be on the left side of the such that bar, and that is true in this case. So x is a bound variable. On the other hand, y is a free variable, because just like in the previous example, if we plug in different values for y, it's going to change whether or not this overall statement is true. So if we picked an element that didn't work for the element hood test rule here, then the statement would be false. Whereas if we picked a value that did work for the element hood test here, then the statement would be true. So in this case, y is a free variable. So now the confusing part of this question is C. What can we do with that? So you might be tempted at first to think that this is a bound variable because it is sort of in the brackets here, but actually it is a free variable. Because the meaning of the sentence does change when you plug in different values for C. And by meaning, I mean the truth value of the statement. So if I say C is 0, then that's going to change which elements I can include in this test. 13 minus 2x might be greater than 0, but 13 minus 2x might not be greater than 5 or something. So because the meaning changes, and by meaning I mean truth value, then C is a free variable. There you have it. I hope that you understand sets, elements, and the bound variables and the free variables, and how to identify which is a bound variable and which is a free variable. And this is very important for writing proofs later on, because you'll have to know which variables you're even talking about. One last thing, we can simplify this statement here by writing y is an element of the real numbers and 13 minus 2y is greater than C. And that's how we simplify this statement.